Hello everyone. In this video, I'm going to show you how to run PySEBAL on a newly acquired Landsat 8 data. So we will run PySEBAL on two Landsat 8 data sets which you have already downloaded last week for your exercise with QGIS. So as I mentioned in the last video, this link will lead you to the PySEBAL document for version 3.7.3, and it has all the details which are required to get ready with the data and get it run. So let's see the data requirements for PySEBAL. It's given as a table here. So there are four different categories of data which we require to run PySEBAL. One is satellite data, and satellite data can be Landsat, MODIS, PROBAVI. We have already explained this, and you will be using Landsat data. That's the most commonly used satellite data with PySEBAL 2. And from meteorological data, what we need is shortwave radiation, wind speed, air temperature, air pressure, relative humidity. The units are given here and some explanation are given here. This data should come from meteor stations, or in this case, we will use data from models, the global meteor models available from NOAA, for example. And we need two kinds of data for each of these variables. One is instantaneous, for example, instantaneous wind speed at the time of satellite data acquisition, that means 10:30, 11 o'clock for Landsat, and the daily average, the average wind speed on the day of acquisition. And we need a DEM, digital elevation model. We generally use SRTM for this, and we need soil hydraulic properties. So these four variables from soil hydraulic properties. This is also, in our case, we'll be using from a global data set called high hydro soil, for which the link will be shared in the document itself. For soil hydraulic properties and meteorological data, PySEBAL can read also from numerical data. That means you can either put numerical values as input, or you can put a raster image representing the spatial variation of those variables as inputs. So both can be used in PySEBAL. So let's see how to prepare these data sets for to run PySEBAL. For example, in my D drive, you can see this is the PySEBAL underscore dev, which is the software itself. And I have another folder, module 11 and PySEBAL data, where I have organized all my input data sets. Also a folder for output. So DEM is where I store my DEM data. It's only one. It's static for any corresponding Landsat data. And if we come to meteor data, you can see that I have meteor data for two dates. One is 27 July 2019, and another one is 24 May 2019. And for various parameters, relative humidity, shortwave down, radiation, air temperature, wind speed. Satellite data is where you will store your Landsat data sets. So you can add any number of Landsat data. It can be 10 Landsats or 10 Landsat images. It can go up to 100. It's up to you, the timeline you want to process these data sets. So here what we are going to do is we are going to see how to run two Landsat data, how to run PySEBAL on two Landsat data acquired on 24th May 2019 and 27th July 2019. And this is the soil folder where I have stored the TIFF files representing all those hydraulic properties. And this is also one time because hydraulic properties are static and it won't vary with the timeline. And sebal out is currently a empty folder where all the output should be stored. So this is how I have arranged my folders. It it is better when you have a nicely organized input data, then it will be easy for you. Either way, what you need to know is where all the data sets are. So that is the most important part. Now, to start with, in PySEBAL dev, the first part is you need to, if you go to documents, you need to organize all the input data in an Excel file because PySEBAL has the capability to run on multiple images, multiple Landsat images in single go. But all those time series, all the Landsat images has to be arranged in an input Excel sheet. And with the PySEBAL software itself, there are two Excel sheets provided in the docs folder. One is for Linux and another one is for Windows. So let's open the Windows Excel sheet. And here you can see that there are multiple sheets, and the most important sheets to run Landsat, PySEBAL on Landsat is general input, meteo input, soil input, and Landsat input. The first four sheets has to be filled. So in the general input, if you want to know each column what they represent, please go to the documentation again, and here there is a link for PySEBAL data preparation and execution. Here I'm explaining what each columns are, each columns in each sheet are. So please refer to that. So let's start filling in columns for two Landsat data. So first it's asking input map. Input map means the input satellite data. So here we will give the path to input satellite data. For me, this is the path. And now it's asking output map. So what I will do is I will give this as the master folder, and but I will also add the Landsat, the name of the Landsat data as the final output folder. And this final output folder will be created by PySEBAL output, PySEBAL. You don't have to create it manually. So this is where uh, all the outputs for each Landsat images will be stored in this corresponding folders. So you have to give the name of the Landsat image here explicitly. Now here, image type, if it's Landsat, put 1. Now here it's asking for a DEM, name of the DEM. So go to DEM, and here you have to note that you have to give the name of the file also. So this is how you will fill one row representing one Landsat image. So if you have two Landsat image, you will add the details of the second Landsat image here, third Landsat image. Like that, you can add any number of Landsat images. You can move this red part. Those are just text. Um, Most importantly, please save it into a different file so that you can reuse the original file again. So I'm going to save it into a different name. Now let's go to meteo input. Yeah, here you can see in the first column by default we have given some numbers. So temp means it's the instantaneous temperature. So you have to give the path to instantaneous temperature file. So in my case, it is in meteo. um, this is the instantaneous T air underscore instantaneous. You also have to make sure that you are selecting the right date as well. So I will select this path. I'll add it here and also copy this one here. Yeah. And temperature 24, T air 24. The only difference is instead of inch, it's 24. So I will just copy this one and change it to 24. Similarly, RH, the only difference is here, the variable. So I will make necessary changes here. ZX is the height at which wind speed is measured. It's generally 2 meters. Now we have wind instantaneous and wind 24 hours. So let's take one of these. And, sorry, here, 2024. Just keep this method as default. This default radiation method. Now this is RS24 means shortwave radiation 24 hours. So I will take this one. Yeah, transmissivity you can keep it like that. Method radiation instantaneous is also one. Um, Now this is RS in instantaneous, which is shortwave radiation instantaneous. So I give it like this. And these two are optical height, the height of the vegetation, and so transmissivity. This you can keep the default values. So this is how you can fill the meteor part. And in the soil part, now some numeric values are given, but you have to, or you can replace it with path to soil data. So here, so the first option is saturated soil moisture content. This is, yeah, this is topsoil. So we will add like this. This subsoil, so you can just edit it here. Now this is residual soil moisture content. This is the residence reference content. You can keep the path same but change the file because they are all in the same folder. Now I will can this is the subsoil. So field capacity is this file. The first one WCP F2 topsoil. Back here. We'll copy it again. And wilting point is WCPF 4.2 topsoil. So I'll copy this one, paste it here, and the only difference is 0.2 here. Okay, so these two are you can put default or change accordingly. Those are numeric values. Then, so this is the soil input, and one advantage is that these files are static, so you can repeat this for other rows if you have more Landsat images to run. Then let's come to the next sheet, Landsat input. So here, what you have to add is your satellite data input, and usually if you haven't changed the name of this folder, you can see that name of this folder is same as the prefix of the or each bands. So like this one, see this much part, this is same as this one. So this is what you have to enter here for each Landsat image. That's it. So Landsat number is 8. If it is 7, you can add 7 here. The number of thermal bands is 2. These constants are important for computing cold and hot pixels, and I'm explaining the relevance of these numbers in this documentation. So please go through the documentation and find out what they represent. So that is it for the input Excel sheet. Once you are done with it, you can save it and close it. But now I'm going to add the next line also to prepare data for 27th July 2019. Now you can see that I have filled the next row also for the second Landsat image, which is 27th July 2019, as you can see here. The output map is also changed. The master folder is same up to PySEBAL out. Only the inner folder is different with two different dates. So all the outputs for this Landsat image will be stored here. This is same, image type is same. The DEM is always going to be same because it's the same DEM as long as you are in the same study area. Meteor input also, you can see that in the first one, the date 24/5/2019, the second one 27 July 2019, so corresponding rows. So the rows should be same. The first row representing 24th May 2019. All the data in all the sheets should correspond to that particular date in these 4 sheets. So similarly for other rows as well. So in Meteor data, you can see that here I have changed all the inputs to this particular date, and all the constants are same. One helpful tip would be to use to select a row and use Control H, where you can find this particular date and replace it with this particular date. you should not forget to select this row. Then it will replace all these values to this. So the point is you copy the first row to the second row and then do the replace. So that is a tip. The soil input, I just copied the first row to the second row because they are going to be same. In the Landsat input, you can see that I added the prefix or the folder name of the second Landsat image here. Rest everything I have put same. So that's it. This is how you prepare the input Excel sheet. Now, before running PySEBAL, we have one more step to do. So this is a data folder. You go to PySEBAL underscore dev package, and inside the Sebal folder, there is a Python file called run underscore py3, and this is what you will use to run the Sebal code. So you have to do some editing there as well. So I will open it in Notepad++, and here you can see that the user inputs, user inputs up to here. So the only user inputs you need is the line 14, 15, and 16. The 14 you have to give the path to input Excel which you have just prepared. So for me the path is almost same. The only thing is I saved the Excel sheet into a different name. So let me see what it is. Yeah, this is what I've saved. So I select that one and I replace this. So you have to make sure that this path is correct in your machine. Now it's asking for the starting row number and the ending row number. So in my case, the start row number is 2 and the end row number is 3. So if you have 10 images or 9 images, the start row number will be 2 and end row number will be 10. Then the PySEBAL code will run or loop through each of these columns. So I will close the Excel sheet. I will change the ending row number to 3 because I want those two images to be processed in the same go. You can also select 2 here, so then it will run only the first row. So you can select a sample of rows using these two parameters. That is it. I mean, those are the editing. One important part of PySEBAL is that PySEBAL takes the extent of DEM, the elevation file, as the extent of all the outputs. So for example, in this case, this is your Landsat scene. This is the entire Landsat scene. But the DEM you're providing just covers your Miandop area, and that is our study area. So if we give the DEM only for this area, PySEBAL will run only for this area. All the outputs will be clipped on over only to this area covering DEM. So that is how you will clip your PySEBAL run or limit your PySEBAL run to your study area. You have to prepare DEM in such a way that it is limited to your study area. So once you are done with all the data preparation, Excel sheet preparation, and editing the Python file, which I just showed, you can now open OSGeo4W shell. Please don't forget that you have to enable the py3 environment. Now go to D drive because my PySEBAL package is in D drive. Sebal folder, and let me do a ls to list the files. What is there? You don't have to do it. Okay, it's there now. Python. If everything is right, there are no issues with your setting the paths, then Python run py3.py should work. It may take some time depending on your machine's capacity and size of the study area. Another important thing which I wanted to mention in the beginning itself was, please try your best to make sure that there are no space in the paths. Okay. Yeah, that will, in all the paths, whatever paths you are using in any scripting, it's better not to have any space. Instead of space, I always use this underscore. So it's a good practice. It will avoid unwanted breaks while running the code. But for PySEBAL, it should run with the space also. But that could be one suspect if you encounter any issues while running. It's still running for me. I will not open the any files inside the output folder, but I'll just show you what is happening here. If you go to Sebal out, you can see that okay, it has created the first folder, output folder, and start creating files. It's not yet done, it will take some time. Okay, so it's running, and I hope you will be able to follow this video and get this get PySebal run for 2 times that image. Thank you. So for me, the Sebal run is over. So here in the folder, you can see that in the Sebal out, I have 2 folders here now with storing all the outputs. So let us go to one of these folders for 24th May 2019. So the output, if the Sebal has run properly, you can see 3 folders. There is a log file which will give you some information about all the constants used, thresholds, computer thresholds, etc., etc. So it will give you some idea about the run on those particular day. Biomass production, as the name suggests, give you all 3 layers related to biomass, also biomass water productivity. Output evapotranspiration is where all the evapotranspiration related files are saved. For example, this is the 24 hours ET Act, actual evapotranspiration for 24th May 2019. So this is the image which you will use for to create monthly and seasonal evapotranspiration. There is potential ET, reference ET, the KC, and the ET is also split into transpiration and evaporation here. Those files are also saved here. This is the actual evaporation and this is the actual transpiration. And in the vegetation, all the vegetation related and the temperature related files are saved, like NDVI, SAVI, albedo, the vegetation cover, etc. The details of all the output files are again given in this particular documentation, where details of the output. So in each folder, what each diff file represent is explained here with the units. So please refer to the documentation again, how the output is structured. Um, yeah, that's it for PySebal. Thank you.